So to show you how we're going to make a core mod, we're going to make a mod calling anti-cacti. What it does is it will simply make it so that cactuses, or cacti, sorry, don't do damage. So what we're going to do by doing this is we're going to transform the block cactus class. So let me find that just to show you what line we're going to change. Okay, we got here, we got a block cactus class, and I already know which method it is. Let me just find it quickly so you can see. Okay, so we've got an onEntity collided with block method here. We're going to be changing that, and just removing this line. So I'll show you how to do that. Now, I should also say that there are better ways of doing this. Obviously, you can do this without a core mod. What you could do is you could tap into a player attack event, which will that'll fire an event when a player is attacked, and you can obviously cancel the event from there. But I'm just going to show you how you do it with the core mod. So yeah, if you're going to actually add this feature, don't do it with a core mod. But that's what we're doing now. Okay, so first thing, I'm going to create a new class. I'm going to call it anti-cacti plugin. The reason we call it a plugin is because well, we're going to implement something called IFML loading plugin. So every core mod you make has to implement this, and I'm just going to generate the override methods. I'm just going to get all of these. Okay, so if we're implementing them, we have to override each of these methods. So let me tell you what each of these methods do. So this first one, get ASM transformer class, will be a string array and it will list all the transformer classes or class transformers that you've got. Get mod container class will be a string pointing to the mod container class. So you don't have to have this, but if you say want to have your mod show up in the mod list, like when you're in the actual game, then you'll need to add one of these, and we will be adding one of these. Get setup class. Well, these two you don't really need to worry about, but they're basically about calling things before Minecraft's even loaded. So if you've got to load stuff up, don't even call anything that's Minecraft related there. And get access transformer class is basically helping with access transformers, but there are other ways of doing that. So we're only going to be dealing with the get ASM transformer class and get mod container class. So we can also add some annotations. We actually will be adding some annotations. One of those is MC version. The reason we want to add this is it will limit the Minecraft versions which you can use with this mod. So we don't want this to run anything but 1.7.10. So that's why I'm going to add this. And another one is transformer exclusion. So what we're going to do here is this is going to contain this folder. Basically, transformer exclusions will be the list of things which we are not going to run the class transformer system through. They recommend that any classes which we do class transformers or ASM related things, we should not do it, run it through. So we'll add it to our transformer exclusions list. I should actually put this in curly brackets because it's supposed to be a string array. Okay, so that's all we've got for now. Let us create a new class. This will be our last class transformer. Okay, again, so this time we're creating a class transformer. Now the class transformer is in charge of will receive information about every single class that comes through in its bytecode format, and then we can transform it. So we need to, hold on, we need to make it implement iClass transformer. And again, I'll just generate the override methods. So it's only this one. So basically what this is this transform method is going to be called every single time a class is loaded or about to be run. And the first value will be the name of the class, so that will be the path, I guess. Transformed name. This is the deobfuscated name of the path, so this will always. So if name and transform named are different, that's an easy way to tell if we're in an obfuscated or deobfuscated environment. And this is the class being transformed. So this byte array is actually our bytecode that we're going to be transforming. So what I like to do is I am going to create a list of strings which contains all the classes that we're going to transform. So in our example, we're going to be transforming block cactus. So the name for that is net.minecraft.block.blockCactus. And we're going to be checking if against the transformed name, because that will always show up as the deobfuscated name, and this one will either be the deobfuscated or the obfuscated name depending on the environment, sorry, not the environment, so yeah, where we are. So usually what I'll do is I'll firstly set up a a boolean for if we're obfuscated. So yeah, what this has done is boolean obfuscated will return true if we're in an obfuscated environment because of this. If they're the same, then we're in a deobfuscated. Now I'm going to find out if the transformed name or the name of the class that's going through is in our classes being transformed list. So I'm just going to refer to the index of its position in here. And remember, if the string is not in there, it will return -1. So we're going to check if it's -1. Okay, so this index will return the position in this array, and we're going to return the index not equal to -1. So if it does come through, we're going to transform it again. Oh, not transforming class being transformed and is obfuscated. So I'm just going to create a new method here. Okay, so just to run through this again, we're going to check if the transformed name is in our class as being transformed, and then we're going to see if return the index of the position. If it's -1, which we're doing here, a ternary operator, then we're going to go here. We're just going to return the actual class itself. We don't want to do any modifications if it's not on the list. If it is, we're going to return the transform of it. So firstly, I'm going to print line saying, transforming, and then I'm going to go, oh, you know what, I was silly and made them similar, okay. Classes being transformed index. Yeah, what I did here was actually I meant to put classes being transformed. I should have made these names a bit different, but anyways, you can see what's happening. So this will print out the name of the class we're transforming. Okay, now we're going to try to do this because there's always room for error to happen. And if not, we're going to return class being transformed. Okay, so we're going to try and transform the class. If not, e.print stack trace. Okay, so we're going to do a switch. Sorry, not a switch already. We're going to create a class reader. So what the class reader will do is pretty much take the bytes in it and make it into an ASM readable format so that we can go through the instructions and view each of its information. So to do that, we've got to make a new class node. Make sure that it's importing from here, the org.objectweb.asm.tree.class node. I'm going to make it a new class node. Oh, didn't mean to do that. I've got to give it a name too. And a new class reader. So this is what's going to read the class. Equals new class reader. And we're going to make it read the class being transformed. And we need to call this accept class node 0. So you just understand that we need to do this. We'll explain exactly what it does. I'm not too much sure on that, but what this does is basically after you do this, we'll get a class node which we can go through each of the instructions and each of the methods and iterate through all of them as we need. And we'll also need to, we're going to be doing our transformations in this section, in this middle section, so we need to turn it back into the byte format. And to do that, we're going to get a class writer. Class writer equals new class writer class writer.compute maxes compute frames. So what this does is when you change some ASM code, and for example, there's some variables that are changed. They're called the maxes and the frames. If you want to avoid having to automatically change the max values and the frames, you should put these in. Maxes, for example, you have to specify the max size of the stack that you'll need and the max size of the local variable table. But ASM will compute it for you if you put these flags in. Okay, so and then we'll class node accept class writer, and we'll return class writer dot to byte array. So make sure you've got these in it. What this will say again, this will turn it into something we can read. This will turn it back. Okay, so what we're going to do is we're going to transform it now. Now, the reason why we had this string array at the start is if we're going to have more than one class. So what I'm going to do is I'm going to do a switch array. Not a switch array, a switch which will we're going to check against the classes being transformed index. So if we're in the index of 0, which is the block cactus, then we're going to transform block cactus, and I'm going to make this method in a moment. Okay, and break. Okay, so now I'm going to make this transform block cactus method. I usually have a method for every single class I transform. It helps make it not one big huge wall of text. Oh. Why did I put a comma in there? Block cactus class boolean is obfuscated. Okay, so now since this is going to be stored as a reference, we don't need to return anything. This will pretty much just edit the class node class, and since we're editing a reference, we're going to just be editing the actual class node. Okay, so first thing, we are going to find out the deobfuscated and obfuscated names of the method that we're going to be transforming. So the actual name of this was onEntity collided with block. So what we're going to do is we're going to open MCP mapping viewer, which I've got open here. You should have it ready. I'm going to show you how you find your MCP maps. Sorry. Firstly, you're going to want to go to your user folder. So this is not my user folder, sorry. You want to go to your users. Oh, yeah, that's my username. Nope. And then go to .gradle. Rep. Oh wait, not that one. My mistake. We're going to D drive. So I've got mine in my D drive. So you need to find your .gradle folder. So that's where all your forges and stuff is saved. Then you'll go to Minecraft. Oh no, you go to caches. Sorry. Minecraft net, Minecraft forge, and you'll find the latest one. So I've got the latest here is 1277, and you'll want to click on unpacked, and that MCP folder is going to contain all the stuff that this needs. It's going to load from conf, which contains all the data, and we've got every single class here and method that we're going to be using. So in our case, we're going to use block cactus. That's here. Just going to take this up. So we're going to find the method that we had, which is onEntity collided with block. And you can see we've got the method descriptor here, which is useful for us. So if we compare against it, you can see that we've got the world integer entity, and here we've got world III entity, and it returns a void. So this is just making sure that it's the right one. So what I'm going to do is not that one. I'm going to create a string. And I'll make it with the obfuscated name for this method is A. So I'm going to do that. And onEntity collide with block. However, because when the class is obfuscated, there's many classes that are also A. The way that we differ them is with the descriptor. So I'm also going to write down the descriptor. That's not the sig, sorry, the descriptor. And so that'll be is obfuscated. So we already know that this is the descriptor when it's in a deobfuscated environment. You can just click on it and press Ctrl+C, and then that will paste it there. But we need to actually manually find out the obfuscated names of the world and entity. So I'm going to search up world up here, and we'll find it in this list. So we've got world here. And the obfuscated name is AHB, so I'm going to replace that with AHB, and entity is SA. So whenever we're in deobfuscated or obfuscated, we'll know the method name and the descriptor because we're checking if it's obfuscated. So that's why we checked if it was obfuscated. Okay, so now we're going to find the method. Since we're only given the class node, we need to find the method that we're going to edit. So we need to enter that one, method, cactus class dot methods. So the methods in a class are actually stored as an array. If you go block cactus class dot methods, you can iterate through them like this. This will just be a for loop going through every method. So we're going to check if method dot name dot equals entity collide and method dot descriptor dot equals entity collide disk. And so now we'll have the method onEntity collided with block ready to transform. Okay, so now we need to find the instruction we want. And now you may be thinking, well, how do we know what the instructions are? Well, I've installed the plugin which allows us to view the bytecode outline, which I explained in the previous section. To view that, we got to have the class open and click on Code and go to Show Bytecode Outline. And what this will do is show the bytecode for the class. So if I search for the onEntity collided with block, here's the onEntity collided with block class, so method, sorry, not class, and it will show all the information. So you can see the local variable table here. So we can say that the local variable for 0 is this. Local variable for 1 is at the first parameter here, which is the world. Local variable 2 is the integer here, which I'm guessing these are x, y, and z. And so even if they're not used, they'll be there. And we can see that there also is some line number stuff, but we don't need to worry about that. That's for when you've got errors and things. They'll use the line number to show, what line the error occurred on when, say, you get an exception or something like that. So first, you can see that they're doing a load 5, which is loading the entity here. Then they're doing a get static here, which is loading damage source.cactus, which you can see here. This is the first parameter for attack entity from, and fconst_1 is loading 1.0f, which is our float value for 1. So we've loaded the instance that we're doing the method on, which is the entity, and doing get static and fconst_1 to load the parameters. And then we invoke a virtual method, which is this net/minecraft/entity/entity.attack_from. So that's the method name, and here is the descriptor for the method. So when we're viewing in the bytecode outline plugin, it actually shows it as it would be in the constant pool. So it doesn't just give us the number in the constant pool to save us from that hassle. So when you compile it, it'll replace that with the number in the constant pool, but we only need to worry about that. So that's why I said you don't need to worry about. And then since attack entity from actually returns an integer, if I'm not right, so a boolean, yes, so it returns a boolean. We don't actually need that boolean. We're just saying that we're attacking it. So we'll pop it off the stack, and then we'll return. So that's what that method has done. However, we are going to view the ASMified version, which is very similar, and it allows us to view each of the parameters and arguments, each of the instructions that we can iterate through. So here's, if I've clicked on the ASMified tab up here, and we're going to find onEntity collided with block method. So here is our method that we're going to be transforming. So each of these, so we're going to start here. That's the first instruction. That's the first thing after mv.visitCode is the first instruction. And this is just a new label. So that's not an actual instruction. So this is the first instruction. This is the first one, second one, third, fourth, and so on until you get to visit ins and return. When you get to the last visit label, it stops. There's no more. So this section here is the instructions that we're going to go through, minus that that label there. So yeah, labels are the branches that I mentioned before when we were talking about conditional. So if we were to branch from, say, if we did a go to L1 in, say, if we just inserted a go to here, then it would just physically move to this section here where we go visit label L1 and then continue from there on. Obviously it would return an error because we've got stuff in the stack and we've ended the method and we haven't popped it off. Okay, so now we understand that. You can see that we've got the instructions here, aload5, the get static, fconst_1, invoke virtual and pop. These are the 5 instructions we're going to remove. If we remove those, then it'll be as if that line was never in it. So we're going to iterate through all the instructions in the method. So firstly, we need to find the ALoad5 method. Now, we need to find the ALoad5 instruction. Now, when I was talking before about how it's very hard to, have transform the same method if that method changes, well, what we can do is instead of just saying get the third instruction in the bytecode, what we'll actually do is iterate through it and find the instruction instead. So that means if say they inserted a line beforehand and it's not an ALoad, then it'll still find the right instruction for us instead of finding an other one that we had. And then we'll check if the variable in it, or sorry, this number is a 5, and I'll show you how you do that now. So firstly, we're going to create an abstract instance node. So this is basically the cover all bases instruction node. So every single node for an instruction is an extension of abstract instruction node. I'm going to make it null for the moment. You'll see what I'm doing in a moment. And we're going to go abstract instance node instruction method.instructions.toArray. So the method.instructions is actually not an array like the methods were. It's something called an instruction list. And if you do a .toArray, it'll turn into array, which we can iterate over. Okay, so now we're going to check if the instruction we're going to check if the opcode for the instruction is equal to ALoad. Now, we need to import something. So what I'm doing here is if I go to the opcodes class, you'll see that every single opcode that there is in this list, and it's all just an integer thing. So, the opcode for icons_1 and the byte form was a 4. So instead of just, remembering all the bytes, what we can do is import a static version of this, and it will allow us to have ALoad like this in here referenced from there. If we didn't have the static there and just imported opcodes, then we need to do opcodes.aload for each of them. But since you'll be doing a lot of these, it's a common thing for people to import a static version of it. Okay, so we're going to check if the instruction is an ALoad. If it is, then we can safely cast the type to a variable instruction node. So yeah, an ALoad, if we look at it in this list, is a variable instruction node. Each of these are in they're different categories. So everything from here to here is in a visit instruction node, integer instruction, LDC instruction, and so on. So this will help tell you what type it is. And also you can see in the bytecode we've got a visit variable instruction node here. So we know that that's the type. So we're going to check if instance node instruction dot var is equal to 5. So if we go into the code for the variable instruction node, we can see that we've got the var here. This will be set to the value here. So we can check if that's 5, and if that's a 5, then we're pretty sure it's the instruction. But just to be sure, I'm also going to check if the next instruction is a getStatic instruction. So, just to make sure, in case someone adds an ALoad instruction before it anywhere, this will allow us to just make sure that it always is the right one. So yes, when you've got an instruction here, you can actually do .getNext, and that will go to the next instruction in the list. And I'm going to check if that's a get static. Okay, so now that's over, we're pretty sure that once it's passed this check, it's the instruction we're looking for. So I'm going to set target node equal to this instruction. And I'll break the loop so it doesn't continue going in case it's any more afterwards, since we know it's going to be the first one there. Okay, so we're going to check if target node is not equal to null. So basically, if we did find the A-load instruction that we're looking for, then we're going to transform it. Else, we're going to cause an error. I'll let you work that out. I'm not going to do any error handling right now, but you can add it into your own code if you wish. So what we're going to do is I'm just going to copy this for reference. So if you were looking back on this code later, you wouldn't need to open up the ASM version to understand it. I'm going to tab. So we're going to remove this. So what we're going to do is we've got the target node here. We know that the target node is going to be on the first instruction. So what I'm going to do is I'm going to iterate through each of these 5 and remove them. The issue is that we can't just remove the target node first thing, because if we remove the target node, then we'll lose the reference and won't be able to remove the 4 afterwards. So what we're going to do is I'm going to iterate through and I'll change the target node to the one after it. And then I'll remove the previous value. So this is pretty much a workaround from the fact that we won't lose a target node value. Instead, for 5 things, we'll start off with this as the target node, then we'll jump to here, and then remove the previous value. Then we'll jump to the next one and remove the previous value. And we'll do that 5 times and we'll have removed all 5 of these. Okay, so, and the way you remove something is you do method.instructions.remove. This is why we have the instruction list, because so we can have a .remove on it. And target node .get previous. So yeah, there's also a get previous, and that will get the previous one. And so what this will do is actually remove it all. And it should be working now. I'll just quickly check for a moment. Oh yes, we also need to add it into the plugin itself so we can actually test it out. So to add it into the plugin is we're going to add it into the here. So com.vac dot anti-cacti class transformer. So remember, as I said, you're going to add the location of this get ASM transformer class. It'll need to be a new string array for it. And we also need to, because we're in a deobfuscated environment and we haven't put it into the build.gradle, the build.gradle allows us to find the core mod, but when we're running it in our current configurations, it actually doesn't know that we're running it, the core mod. It's going to look for a main method, but it can't find any. So we need to add in an option here so we can test it out in our debug, sorry, in our dev instance, and that is dfml.coremods.load equals com.vac.step.anti-cacti plugin. And so when we play, it should load up properly. Okay, so I'm going to click OK. And hopefully, let me just double check everything. it should work. So, it shouldn't throw this error, but now we've gone through everything, it should work. Okay. Exit code 1. Oh yeah, that's right, I've done a typo. It's a capital D for... There you go. I'm going to try it again. So make sure you've got that capital D as the thing, because it's not going to work if it's a lowercase d. So you can see in our log we've printed out transforming net.minecraft.block.block_cactus, showing that we've successfully found the class in this list, and now we've got Minecraft loaded. Now obviously we're not actually going to see this in our mods list because we haven't added it to it. However, if we create a new world and we try and get damage from a cactus, it should not damage us at all. See, here's a cactus. Oh. And gonna turn myself off creative mode again. And I took damage. That's not supposed to happen. I've done a typo here. Sorry about that. Okay. And we take no damage whatsoever. So we can see that our core mod has successfully worked and we physically changed the code. However, I've got some bad news for you. We've done it a way that makes it possibly incompatible with other mods. The right way we should be doing it is we should be wrapping this in a conditional if statement. So what I mean by that is we're basically removing it out flat completely or every time. Let's say one day we want to add a config option. That's not in our minds right now, but let's say it's in the future. Well, this has no flexibility whatsoever to do that. We want to make it easy to add things and remove things. So what we're going to do is I'm just going to make a quick variable up here for us to check if we're doing the bad method. So private static final boolean is bad method equals false. So I'm just gonna quickly do is bad method. So I'm just gonna leave this here in case anyone wants to look over this in the when I upload the code to GitHub a bit later. So don't ever do this because you'll get a little bit of flack for it. It's not the right way to be doing it. What we're going to be doing is we're going to be let me get the bytecode on it again. What we're going to be doing is replacing I'm just going to copy this. Replacing with if hooks.cactus does damage, okay, so that's what we're going to be doing. Now I'm going to make a new class here called hooks. It's the what I call it, but you can call it whatever you want. And I'm just going to make a new method here for us to use. Public static boolean. Let me just go back and check what I called it again. Cactus does damage. Return true. Wait, actually I'll return false because we don't want the cactus to do damage. So what I'm going to do is I'm going to actually turn this into bytecode so you can see what it will look like before and after. So bytecode replacing, and I'm going to copy this and we're going to replace it with I'm just going to paste it back here again so I can show you what we're doing. We're going to add in invoke virtual. Wait, I'm going to do this one thing. Invoke virtual hooks.cactus does damage. And we're going to go if eq, which is going to check if this is 0. If it's 0, then we're going to branch to new label node. And down here, I'm going to put a new label node. Now, I'm not going to put this bytecode in this format. It's just to show you what's different. So anything I type like this is going to be different from what we're actually doing. So now we've got this here. We know what we're doing. Let us start doing it. So first thing is we want to find the pop node. The reason we want to do this is because we want to insert the new label node afterwards. So to find the pop node, I'm just going to make a pop node here. Now what we could do is just do target node.getNext.getNext.getNext 5 times, but to make it look a little nicer, I'm just going to do an for loop. I do I less than 4 because it's technically 4 after the first one. And I plus plus pop node equals pop node dot get next. And once this is done, the pop node should be down here. Okay, so I'm going to make a new label node. New label node is equal to a new label node. So that's where we're going to be jumping to. Okay, so now we're going to insert these 2 lines of code. Now, you could just insert it one at a time, but if you're going to be inserting a lot of code at once, what you can do is create an instruction list and insert it into the method.instructions. As I said before, method.instructions is an instruction list. So you'll be inserting an instruction list into an instruction list. So let me make a new instruction list. And so it's going to be a new instruction list. So we're going to insert a new instruction here. Now this instruction is actually going to be a method invocation node, and we're going to be invoking hooks.cactus does damage. So let's show you how we do that. So firstly, we're going to make a new method instruction node. So remember, invoking a virtual is actually a method instruction node, like here. So we're going to make a new one, and the parameters for this, we're just going to show you over here. The parameters for a method instruction node are not there for me to quickly click on. Yeah, so you can see here we've got the opcode. So this will be invoke virtual. The owner of the string, so that's going to be the name of the class that the method's owning. This is final string names going to be the name of the method. This is going to be the descriptor of the method. And ITF is if the method owner's class is an interface, which it is not. So that will be false. So first off, we're going to type in invoke static, so that's the opcode. We're going to get the name of the hooks class. We could type it out, or we can do this get internal name hooks.class. So this just allows us to get the actual internal name of the class. It works fine. And the name of the method we're calling is cactus does damage. And where the method descriptor is actually just this, because we're taking no arguments, and we're outputting a boolean, and boolean is z, and false, because it's not an interface. And the next instruction we're going to be calling, adding to it, is what is it? Sorry again. A new if equals jump label node. Sorry, we're going to be adding an IFEQ instruction. Now that type IFEQ is actually a jump instruction node type. So we're going to do a new jump instruction node. Going to make it if EQ and new label node. Now that's all it takes. That's the only two arguments for this is IFEQ and new label node. That's all we're going to be adding there. And then we're going to insert that. We're going to insert before the target node. So basically what we're doing right now is we've got this instruction list here. It's only 2 instructions, and we're going to insert it before the target node, and the target node was ALoad5. So we're going to be inserting it before this section here. And we're also going to insert the new label node after the pop node. So inserts after, insert before, inserts before the node. So if that causes any confusion, that's what basically it means. So now what we've done is we've inserted these two before ALoad5 and inserted the new label node after pop. And so now what it's going to do is it's going to invoke this method, check if it's a 0. If it's a 0, then completely skip everything. If it's not a 0, then it's going to carry out with what it normally would do. And we already know that this is going to be fine, so don't worry about that error. Okay, so now this should work. So we're going to try this instead. Okay, so let's try take damage from the cactus. And we don't take any damage, so we've successfully done our new method. And this method is a lot better, and I'll actually show you why in a moment. So now I've decided I actually didn't want to just disable it for everyone. I only want to disable it for players. Well, now we can easily do that. So what I'm going to do is I'm going to take in a new argument on our cactus does damage method. And what it'll do is it will return entity instance of entity player. So yeah, basically all it'll do is say if it's a player, then return. We want to do the opposite. If it's a player, return false. If it's not a player, return true. So the cacti will do damage to everyone except players. Okay, so let's try and add this in. So firstly, we need to add a new instruction to this list. This instruction will be ALoad5. So what we've done here is we've added in the a reference to the local variable table, and we can see in position 5 we've got the entity which came through. Okay, so this entity is going to be what's being attacked by the cactus, pretty much. And we also need to change the descriptor, because now we're using an entity as one of the arguments, we need to add that in. And since the entity is not one of those simple types, we need to do one of these is obfuscated things again. So let me just type this in. So if it's obfuscated, then we're going to do LSA that. I'm just remembering this from before because I'm remembering LSA semicolon from before when we typed it in here. Sorry, not there. Yes, here. The entity type was LSA that, and the type for the entity is not that way. Is this. Okay, so now when we do it, it will check if it's and now this should actually work. So let's just try this out. Okay, I'm here, and to conveniently a sheep went by to show you. I'll spawn in a new thing for you, in case you missed it. That pigs take damage, whereas we do not. And so therefore we've got our working mod. The last thing I'm going to show you is how to add it into your build.gradle and how to add a mod container for your thing so it shows up in the mods list. I'll do the mod container first. So we've got our entire working mod here. That's all good. Okay, so we're going to make a new mod container class. So I'm just going to call it anti-cacti mod container. And what we can do here is we can extend dummy mod container, sorry. So dummy mod container is something added by Forge, and it's just a simple way for us to add a new mod to the list. Anti-cacti mod container. This is just our constructor. So we're going to add in a mod, so we're just going to add in the information that shows up in the mod list right now. Not modifier, mod metadata. Okay, so what this is going to do is it'll allow us to specify what goes in our mcmod.info file of sorts and shows up in the mods list. So meta.mod ID is equal to, not that, equal to anti-cacti, meta.name equals anti-cacti, meta.description equals stops cactus damage, meta.version equals, and lastly meta.authorlist equals arrays dot as list black step. And if you want to know what you can put in there, you go to the mod metadata file and it shows you all the different things. If you want it to be auto-generated for you, you can set this to true. Auto-generated will just show you, make your author set an mcmod.info file if you want to do that for some reason. And the last thing we need to do is we need to override public boolean register bus, and we need to register this mod. Yep, okay, and we're just going to do bus.register this, return true. Okay, so just in case you're wondering, you can use this like a regular mod. You can subscribe to, your init or MFL initialization events and such. This will automatically be added to those listeners. So, if you want to make any other features you mod that aren't core mod features, you can do that. You can also have an extra folder, which will, so you can have a regular mod and a core mod in the same thing by having your regular mod in one folder, and you can have a separate folder for ASM. And you can specify that you want to have a core mod by editing your build.gradle. So we're going to add a small thing to our build.gradle that will make it so that we can export this mod and have it work. So we're gonna type this in. So firstly, we'll need a new attribute here, fml core plugin, and a new attribute, fml core plugin contains mod. So I'm just going to set this to true, and this one is set to the location of the core mod. So And there you go. You should have a full working mod. I'm not exactly sure where this error is coming from. Hold on. Ah, I forgot to put a name. There you go. So now you should have a completely working mod now. Oh yes, one more tiny thing. You also need to make sure that you're pointing to your anti-cacti mod container class, whatever you're calling it, if you do a get mod container class. So I'll just quickly do that here. And there you go, you should be all good. There's also one other thing I'd like to show you. I haven't included in this mod, but if you want to simplify a bit of the ASM process, there is a Git sub module you can add to your, say if you've got a Git project, you can add a thing called ASM helper. You can also download it, I guess, and it's made by Squeak502. You might know him from Whaler Half Stability or Tinker's Construct Tooltips. And it adds a whole bunch of cool things. I'll put a link in the description of where to get that from in case you wish to add it to yours. I've put it in my own mod in case you want to check through the source code for mine, for example, and find out what I did. I'll also include a couple other popular mods that have core ASM stuff for you to look at if you wish to learn a bit more. So yes, if you have any other questions, put them in the comments and I'll talk to you later.